Have you ever wondered how solar panels work? Picture a world powered by the sun's boundless energy. Solar panels are the heroes of this narrative, harnessing the sun's power and transforming it into electricity. They're not just decorative rooftop additions, they're sophisticated devices that capture and convert sunlight into usable power. But how does this intriguing process work? We're not going to dive into the nitty-gritty just yet. Today we'll explore the fascinating process of how solar panels convert sunlight into electricity. At the heart of every solar panel you'll find solar cells. But what are these solar cells? Well, they're essentially the workhorses of a solar panel, responsible for the magic that turns sunlight into usable electricity. Each solar cell is made up of layers of silicon, a material known for its semiconductive properties. Think of silicon as the middle ground between conductors like copper that allow free flow of electricity and insulators like rubber that prevent electric flow. In a solar cell, two layers of silicon are sandwiched together, one positively charged and the other negatively charged. This creates an electric field. When sunlight, or more specifically, particles of light called photons, hit the silicon layers, they knock electrons loose. This disturbance in the electric field causes these electrons to move, creating an electric current. These solar cells are the fundamental building blocks of a solar panel, playing a crucial role in the conversion of sunlight into electricity. Now comes the magic, the conversion of sunlight into electricity. Let's start from the beginning. Our sun, a colossal fusion reactor about 93 million miles away, sends a steady stream of light particles, or photons, our way. These photons embark on an 8-minute journey from the sun to Earth, and when they reach a solar panel, the real journey begins. The solar cells on the panel, often made of silicon, are like the welcoming committee for these photons. They absorb the sunlight, and this is where things start to get interesting. Within the solar cells, there's a party going on. The absorbed sunlight energizes the electrons, giving them enough pep to start moving around. This movement of electrons is what we refer to as an electric current. But how do we get from a bunch of excited electrons to something that can power our homes? This is where the electric field within the solar cell comes into play. This field, which is created by the positive and negative layers within the cells, acts like a pushy crowd controller. It directs the electrons, forcing them to move in a specific direction. This creates a flow, a bit like water running through a pipe. Now, we have a flow of electrons, but we need to harness it to create usable electricity. This is where the conductive metal plates on the sides of the cells step in. They collect the electrons and transfer them to wires. And just like that, we have an electric circuit. So, in essence, a solar panel works by absorbing sunlight, jostling loose some electrons, directing their movement to create a flow, and then collecting that flow to create an electric circuit. It's a bit like a water wheel, but instead of using flowing water to turn a wheel, we're using flowing electrons to create electricity. And voila! The sunlight is now electricity, ready to power your home. But how efficient are solar panels really? When we talk about efficiency in the context of solar panels, we're usually referring to the percentage of sunlight's energy that a solar panel can convert into usable electricity. On average, this is around 15 to 20%. Doesn't sound like much, does it? But given the immense energy the sun provides, even that modest percentage can power a home. A variety of factors can affect a solar panel's efficiency. Sunlight intensity, for instance, plays a significant role. The stronger the sunlight, the more energy there is to convert. The angle of the sunlight also matters. When the sun is directly overhead, solar panels can catch more sunlight and thus produce more electricity. Temperature is another factor. Solar panels actually perform better in cooler conditions. High temperatures can reduce their efficiency. Despite these factors, solar panels remain an effective and sustainable way to generate electricity. So, to recap the marvel of solar panels, we've discovered the role of solar cells acting as the building blocks of these panels, capturing sunlight. We've seen the fascinating conversion process, transforming this sunlight into usable electricity, and we've delved into the factors that affect their efficiency, including the angle of the sun and the quality of the panels themselves. Indeed, the science behind solar panels is as brilliant as the sunlight they harness to